What if I told you that the finest fighter aircraft of the Second World War never reached combat, not because it was flawed, but precisely because it was too good? That the man who should have cleared it for production did everything in his power to make sure it never flew in series? And that the loss of one pilot in one test flight shut down 3 years of work faster than anyone had time to ask a single question? Today, we are talking about an aircraft that official Soviet documents called the best fighter in the country, about a designer the system used and then discarded, about a man at the peak of power who knew the truth and deliberately concealed it from Stalin himself, and about a piece of copper wire found somewhere it had absolutely no business being by accident. This is not a theory. These are trial protocols. These are frontline regiment reports. These are facts that 80 years of official history preferred not to notice, because if you notice them, the entire accepted picture of Soviet aviation falls apart. Watch to the end, because the most uncomfortable part is still ahead. Soviet aviation in the late 1930s had one chronic ailment, a catastrophic shortage of powerful engines. Not a shortage, a paralysis. While Germany mass-produced Daimler-Benz and BMW power plants pushing well past 1,000 horsepower, Soviet designers squeezed every last drop out of underpowered serial engines that had no business being in a frontline fighter. The performance gap was staggering, and the Kremlin understood this perfectly well. What does it actually take to build a genuinely fast fighter? The question sounds simple until you start doing the math. Speed is not just about the engine. It is about an aerodynamically clean airframe with minimum frontal drag, a carefully planned layout of components, and precision-fitted joints and seams. Every extra kilogram means lost kilometers per hour. Every unnecessary bump on the fuselage bleeds speed more effectively than a weak engine ever could. A fighter that looks like a flying brick will fly like one, regardless of what is under the cowling. Polikarpov understood this better than anyone in Soviet aviation. That is precisely why in November of 1939, after receiving specifications for a new generation of aviation engines from the People's Commissariat, he made a decision that seemed unconventional at the time and proved visionary in hindsight. He chose to design an airframe capable of accepting multiple different engines without fundamental structural modification, not built around one specific power plant, but engineered around an entire family of them. It was a direct engineering answer to the central weakness crippling Soviet aircraft production. The list of candidate engines was impressive on paper. Double-row air-cooled radials, the M90, the M71, and the monstrous M120. As a fallback, the liquid-cooled AM-37, an engine of an entirely different class and philosophy, was also under consideration. Each of these power plants promised performance Soviet fighter aviation had never seen. Each of them existed, on paper. Because the brutal reality of Soviet engine development in those years was this: the distance between a specification sheet and a reliable serial engine was a chasm that very few programs managed to cross. This is the precise point at which the I-185 was born. Not as a response to an existing engine, but as a calculated bet that Soviet engineers would eventually get at least one of these power plants into reliable working order. Polikarpov designed the airframe first, before any of the engines existed in a form fit for operational use. It was an enormous gamble, and simultaneously, the only logical move available when time was running out and war was closing in with every passing month. The aerodynamics of the machine were built around several uncompromising requirements. Achieving minimum frontal drag with an air-cooled radial is no trivial task. By its very nature, a radial is wider and blunter than any liquid-cooled inline. Polikarpov tackled this through meticulous cowling design, carefully engineered transitions between major structural assemblies, and aggressive tapering of the fuselage immediately behind the engine bay. The intended result was a fighter combining top-tier speed with overwhelming firepower, exactly what Soviet air forces were desperately lacking at that moment. The only question was whether a worthy engine would ever arrive to match the airframe that was already waiting for it. On the 4th of March, 1940, the Defense Committee of the USSR signed a decree ordering the development of the single-seat experimental fighter I-185. Not a recommendation, not a statement of intent, a firm state directive with hard deadlines and hard requirements. The Soviet government was officially betting on Polikarpov, and the stakes could not have been higher. The calculated performance figures written into the decree left no room for modesty. Maximum speed, 683 kilometers per hour. Armament, twin SHKAS machine guns, combined with a SHVAK cannon, grouped as a single battery above the engine. A prototype was to be built and ready for state trials no later than November of 1940, 8 months from decree to finished aircraft, in conditions where the engines did not yet exist in any usable form. The requirement was brutal by any standard. 683 kilometers per hour demands context. At the moment the decree was signed, the best Soviet serial fighters barely managed 550. The German Messerschmitt Bf-109G, the primary opponent in the skies over Europe, was pushing roughly 570. In other words, Soviet leadership had built into the specification not parity with the enemy, but decisive superiority over it, not to catch Germany, to leave it behind. And here is what the general public still does not know. Simultaneously with the monoplane I-185, the same Polikarpov Design Bureau was developing its direct twin in biplane configuration, the I-195. A biplane in 1940? An anachronism? A museum piece? Not in Polikarpov's hands. The I-195 was not designed for outright speed. It was conceived as a fighter of exceptional horizontal maneuverability, capable of turning inside any monoplane adversary in close combat where speed alone could not save you. The I-195 figures were specific and compelling. With an identical power plant, the biplane was calculated to reach 510 kilometers per hour at ground level and 590 kilometers per hour at 6,000 meters altitude. In outright speed, it trailed the I-185 naturally. But in horizontal turning performance, it was projected to outclass virtually any contemporary fighter in the world. The idea was to hand Soviet air forces 2 instruments simultaneously, one for catching and striking, one for spinning the enemy into a fatal turning duel with no exit. The logic of this concept was flawless. Aerial warfare is not one type of engagement. Intercepting bombers required speed. Fighter versus fighter combat at low altitude required precisely what the biplane delivered better than anything else. Polikarpov was thinking in systems, not in single aircraft, but in complementary pairs that covered the full spectrum of combat requirements. In 1940, that kind of thinking was rare even by world standards. Both programs launched simultaneously. Both were built around the same engine family. Both depended on the same unresolved question: when would Soviet engine designers finally deliver what the airframe designers had been waiting for? November 1940 was the deadline. Reality, as it so often does in wartime production, proved far less accommodating than any schedule. By July of 1940, it had become definitively clear what many in the aviation industry had suspected from the very beginning. None of the 4 target engines, not the M90, not the M71, not the M120, not the AM-37, would be ready by the appointed deadline. The engines existed as experimental specimens that misbehaved on test stands, fell apart after a few hours of operation, and flatly refused to perform according to their own technical specifications. Soviet engine development had once again let the airframe designers down at the worst possible moment. What does an engineer do when the plan collapses? He builds another plan. Polikarpov made a decision that at first glance looked like surrender. but was in reality the only rational exit from a dead end. If the engines are not ready, take the one that is, even if it is weaker, even if it is inferior. The critical thing was to get the machine flying, to work out the aerodynamics, to identify structural weaknesses, and to stop losing irreplaceable time waiting for engine designers to sort out their problems. The M81 was selected as the temporary power plant, significantly less powerful than any of the originally planned candidates, but proven, reliable, and physically existing in operational form. The power gap was fundamental. The prospective engines in the target family promised upward of 1,500 horsepower each. The M81 produced around 1,100, and that was at takeoff power, in the best case. For a machine designed around a top speed of 683 kilometers per hour, this power plant meant one thing: there would be no meaningful performance figures from this stage of testing. The M81 prototype was not built to set records. It was built to gather data, to understand how the airframe actually behaved in real air rather than on paper. On the 11th of January, 1941, a test pilot lifted the I-185 into the air for the first time. A machine born from an idea, carried from paper into metal over more than a year of work, finally left the ground. For Polikarpov's design bureau, this was the moment the aviation world describes in two words: first flight. Two simple words behind which stand months of calculations, arguments, sleepless nights, and hundreds of revised drawings. The aircraft flew. The airframe held. The aerodynamics behaved precisely as predicted, but the celebration was brief. 16 flights. That was all the M81 prototype managed before a new problem descended on the program. The engine proved catastrophically unreliable, not because of fundamental design flaws as such, but because of its negligible service life. The power plant burned through its operational hours at a rate nobody had anticipated. By spring of '41, the decision came down. The M81 was to be removed from the program. Not refined, not improved, not waited on, removed and abandoned. 16 flights, not 16 hours, not 16 weeks of trials, 16 takeoffs and landings, after which the program had to stop and rebuild from scratch. For any other designer, this might have been sufficient reason to walk away. Polikarpov saw it differently. 16 flights had delivered what no test stand and no wind tunnel could provide: real data on airframe behavior in actual conditions. The machine flew. The machine was controllable. The machine had potential. Everything else was a question of engine. While the design bureau regrouped, workshops were already preparing the installation of the next candidate. The M71, identified from the very beginning as one of the priority options, was finally available in installable form by early April of 1941. Not perfected, not without problems, but capable of running long enough to conduct real testing. That was everything Polikarpov needed to take the next step. In early April of 1941, the second prototype of the I-185 was rolled out onto the flight test apron, this time with the M71 engine under the cowling. The engine was raw, unfinished, plagued by a collection of unresolved problems that the engine designers preferred to discuss in vague terms. But even in that condition, underdeveloped, temperamental, unpredictable, it produced power levels the M81 could not approach even in theory, and that difference showed up in the results immediately: 620 kilometers per hour. That was the figure the I-185 recorded during test measurements with the M71 on an engine that had not yet been brought to its calculated performance. Consider that number carefully. The best Soviet serial fighter of the time, the Yak-1, reached 580 kilometers per hour at full power in ideal conditions with a fully serviceable engine. The I-185 with its raw, unstable M71 beat it by 40 kilometers per hour, and this was still nowhere near the ceiling. The calculated top speed on a fully developed engine was 683 kilometers per hour, meaning the aircraft's actual potential sat roughly 10% above what the tests were showing. This prototype carried for the first time the complete armament package originally specified for the design. Shkas machine guns and a Shvak cannon grouped as a single battery above the engine, a configuration that delivered excellent accuracy and maximum projectile density straight ahead on the attack axis. But the design bureau did not stop there. The second prototype was actively used to develop bombing attack techniques, and it was here that the I-185 demonstrated another characteristic that in 1941 looked simply implausible: 500 kilograms of bombs. The aircraft lifted 500 kilograms of ordnance, an absolute record among Soviet fighters of the period. For comparison, the standard Soviet fighter bomber of that era carried 200 to 250 kilograms at best, and that was already considered a serious load. The I-185 doubled that figure while remaining a high-speed fighter, not a slow-moving ground attack aircraft. What Soviet air forces suddenly had in front of them was the prospect of a machine capable of performing both the fighter and light bomber mission in a single sortie. A universal instrument of aerial warfare, precisely what Air Force Command had been demanding from industry for years and had consistently failed to receive. But behind the brilliant performance figures lay a problem that grew more obvious with every passing week. The M71 behaved unpredictably. Failures were not happening on the test stand. They were happening in the air. The engine could cut out at the worst possible moment, could begin running rough during critical flight regimes, could force an emergency descent precisely where the pilot least expected to need one. Every test flight became a game played by rules that kept changing. Engine designers promised to resolve the problems, but development deadlines slipped repeatedly, explanations grew increasingly vague, and actual progress remained nearly invisible. It was at exactly this moment, when test results were in hand, the aircraft's potential was beyond dispute, and the engine still refused to run reliably, that on the 22nd of June 1941, Germany attacked the Soviet Union. The war that Polikarpov had seen coming long before it began was now real, and it changed everything immediately: priorities, schedules, the entire logic of production decisions. The People's Commissariat of Aviation Industry issued a clear directive within the first days of the war: concentrate all resources on refining and expanding output of equipment already in serial production. Experimental programs could wait. The I-185, with its 620 kilometers per hour, its 500 kilograms of bombs, its full weapons package, was left in limbo. A machine capable of changing the balance of power in the air sat in workshops while war burned across the country, and the engine that was supposed to unlock its true potential still refused to be tamed. Polikarpov decided not to wait, and that decision opened the next, even more turbulent chapter in the story of the I-185. War overturned the Soviet aviation industry within a matter of weeks. What had seemed a promising direction yesterday became a luxury the country could not afford today. The People's Commissariat of Aviation Industry operated on ruthless wartime pragmatism. No experiments, no risky bets on unproven solutions. Only what was already flying, already in production, already familiar to pilots and ground crews at the front. The I-185 with its raw M71 technically failed to meet that standard. Polikarpov responded without hesitation. If the system demanded a serial engine it would get. By that point, Soviet aviation had a power plant that stood apart from the entire family of prospective radials, not so much in raw output as in the simple fact of its actual existence. The M82 produced 1,700 horsepower, was in serial production, had a relatively compact diameter for an engine of its class, and, most critically, worked. Not perfectly, not without problems, but reliably and predictably, exactly what the M71 had catastrophically failed to deliver. Adapting the airframe to the new engine required serious structural work. The M82 was a different machine, different geometry, different center of gravity, different vibration characteristics. Polikarpov reworked the engine bay, recalculated the balance, redesigned the cowling from scratch. The work proceeded in parallel with everything happening outside the design bureau walls. And outside, events were moving at a pace that forced everyone to work faster than they ever had before. German forces were advancing deep into Soviet territory. The front line was closing in on Moscow. In the autumn of '41, the evacuation order arrived. Polikarpov's design bureau and the experimental factory had days to pack blueprints, equipment, and unfinished prototypes before joining thousands of other specialists heading east, to Novosibirsk. The evacuation of Soviet industrial enterprises in '41 is a saga unto itself, the true scale of which history only fully appreciated decades later. Entire factories were loaded onto railway flat cars and transported thousands of kilometers, with production restarting in conditions of Siberian winter, in unfinished workshops, sometimes directly in the open air. The Polikarpov team went through all of it. In Novosibirsk, the work did not stop for a single day. It only accelerated. The I-185 prototype with the M82 engine carried armament that no Soviet serial fighter of the period could match. 3 20mm Schwack cannons with a combined ammunition load of 600 rounds. Not 2 barrels, 3. Not 400 rounds, 600. The 1-second burst from such a machine was capable of destroying any German bomber with the first pass, and against a fighter, it delivered a firepower advantage that none of the Yakovlev or Lavochkin aircraft could approach. Joint factory and state trials of the I-185 with the M82 engine were conducted in Novosibirsk during March and April of 1942. The test protocols recorded results that Moscow could not ignore. The machine flew. The machine was controllable. The machine carried armament that the Germans had no answer to. And the M82, unlike the long-suffering M71, did not misbehave, did not fail in flight, did not demand emergency landings. For the first time in the entire history of the program, the I-185 was a complete, functional, and genuinely combat-capable aircraft. But it was precisely at this moment that a circumstance appeared on the horizon which neither Polikarpov nor his designers could have anticipated. While the design bureau worked in Novosibirsk on the M82 adaptation, something was happening in another design bureau that would prove decisive for the fate of the I-185. That same M82 engine, serial, reliable, 1,700 horsepower, had been installed in the LaGG-3 airframe designed by Lavochkin. The result was designated the La-5. The aircraft was heavier than Polikarpov's machine. It was inferior in flight performance. It fell short across a range of characteristics, but it already existed as a serial production aircraft. Production lines had already been retooled around it. Pilots were already being trained on it. And that single fact had become a slow-burning fuse under the entire I-185 program. On the 20th of November, 1942, the I-185 prototype with the M71 engine entered state trials, this time with the power plant developed to a point where it could be operated without constant fear of in-flight failure. A year and a half of war, a year and a half of evacuation, a year and a half of work under conditions that no reasonable person could call normal, and the result finally lay on the table in the form of official state trial protocols. The figures in those protocols were the kind that made their authors read them twice. 680 kilometers per hour. Not calculated, not theoretical. Measured in real conditions during official state trials. It was late 1942, the height of the war, when Soviet pilots in their Yak-1s and Lag-3s were fighting Messerschmitt Bf-109F and G models at a disadvantage in both speed and vertical maneuver. The German Bf-109G, the best serial fighter in the Luftwaffe at that period, pushed 620 kilometers per hour. The I-185 beat it by 60 kilometers per hour. Not by 10, not by 20, by 60. This was not an advantage. This was dominance. The combat turn, the maneuver by which Soviet aviation traditionally judged the vertical performance of a fighter. At nominal engine output, without boost, without pushing the power plant toward its limits, the I-185 climbed 1.5 kilometers of altitude in a combat turn. The Yak-1 on the same maneuver achieved around 900 meters. A difference of 600 meters of altitude means, in aerial combat, the difference between attacking from above and being struck from below. It is the difference between survival and destruction, maneuverability, stability, controllability. Across every one of these parameters, the state trials recorded ratings of good and excellent. The aircraft handled confidently at high angles of attack, flight regimes at which many contemporaries fell into spins and demanded exceptional pilot skill to recover from. The I-185 forgave mistakes. It did not attempt to kill its pilot at the first opportunity, a rare quality in a high-speed aircraft of this class. The protocols stated explicitly, the aircraft is accessible to pilots with limited training. In wartime conditions, when Soviet flight schools were producing pilots after minimum hours, this was not a technical specification. It was a strategic advantage. Test pilot Pyotr Mikhailovich Stepanchenok, a man who had flown more than 800 types of aircraft in his career and whose word in Soviet aviation circles carried no less weight than a commissariat order, gave the I-185 an assessment that in the aeronautical world of 1942 could only be described as sensational. Stepanchenok noted the aircraft's outstanding flying and speed qualities, pointed to genuine potential for further development through engine boosting and structural weight reduction. His conclusion was unambiguous. The aircraft is highly promising and deserves immediate serial production. Reserve for boosting is not an empty phrase in a test protocol. It meant that 680 kilometers per hour was not the ceiling of the machine. It was its current non-maximum figure. A boosted variant of the M71 with a calculated output of 2,200 horsepower already existed on paper. Basic arithmetic showed that on such an engine, the I-185 was capable of reaching speeds no serial fighter in the world could match in 1942. Not German, not British, not American. Stepanchenok understood this. Polikarpov understood it. The question was whether the people holding the decision on serial production understood it too. State trials concluded. The protocols went to Moscow. The aircraft had passed every stage of official evaluation and received ratings that any other designer could only dream of. The machine was ready. It was waiting for only one thing, the decision to begin serial production. And it was precisely at this moment that a man entered the story of the I-185 who did everything in his power to ensure that decision would never be made. State trials are one thing. War is something else entirely. NIIV/VS protocols are persuasive on paper, but the front asks questions that no test airfield can answer. How does the aircraft perform in an actual combat sortie? How do mechanics service it under field conditions without equipped hangars and specialized tools? How do pilots accustomed to serial production aircraft master an unfamiliar machine? It was to answer precisely these questions that 4 I-185 prototypes were sent to the Kalinin Front in late '42 to the 728th Fighter Aviation Regiment. The choice of regiment was deliberate and precise. The 728th IAP carried a reputation that took years to build in Soviet air forces. The regiment had been formed from flight instructors of the Chuguyev Flying School, men who had themselves taught others to fly and understood aviation hardware at a level unavailable to the ordinary line pilot. The technical staff matched the flight crew, experienced, disciplined, capable of working with an unfamiliar aircraft without panic and without crude errors. If the I-185 performed well here too, the machine was genuinely ready. But command imposed a condition that to this day looks like a slap to common sense. Pilots of the regiment were categorically forbidden to cross the front line. The loss of an experimental aircraft over enemy territory was classified not as a combat casualty, but as treason against the motherland, with all that followed, a shooting offense. Not a warning, not a reprimand, not demotion, a shooting offense for losing an aircraft in combat. This is precisely why almost no records of actual air engagements in the I-185 have survived. The aircraft flew in pairs, made one pass from altitude, retreated at full boost toward their own airfield, and avoided prolonged maneuvering combat. A forced, insulting, and absurd tactical restriction, because it was precisely in extended combat that the I-185 had every chance of demonstrating what it was genuinely capable of. 40 combat sorties. That was the total flown by the 4 I-185 prototypes within the 728th IAP during the field trials period. 40 sorties on experimental hardware not yet accepted into service, not supported by any established maintenance infrastructure, without a functioning spare parts supply chain, without proven field operating procedures. And across those 40 sorties, not a single serious failure, not one forced landing attributable to technical causes, not one flight incident traceable to a design deficiency. For an experimental aircraft making its first appearance at the front, specialists describe this result in one word: exceptional. At the conclusion of the field trials, officers of the 728th Regiment compiled a final report. The document was written by military men, without literary embellishment, without diplomatic hedging, with the directness that the front produces faster than any other school. The conclusion read as follows: the I-185 is currently the best fighter-type aircraft in terms of ease of handling, speed, maneuverability, especially in the vertical, armament, and survivability. Pilots are awaiting this aircraft at the front with impatience. The best, not one of the best, not promising. The best, without qualification, without conditions, by the assessment of men who fought on real hardware against a real enemy. Survivability, the word singled out in the report on its own line, deserves its own attention. Soviet pilots of 42 had extensive and costly experience with German anti-aircraft artillery and enemy fighters. They knew which aircraft came apart from a single burst, and which ones limped home with a punctured wing and a jammed aileron. The I-185 stood in their assessment alongside those that limped home. The structure absorbed damage. An air-cooled engine, unlike a liquid-cooled one, did not drain away and did not seize permanently from a single hole in the cooling system. This is not a technical detail. It is the difference between a pilot who returns to base and a pilot who does not. The report went to Moscow. The 4 prototypes returned to the factory. It seemed as though everything had been settled. The machine had passed everything: state trials, field trials, evaluation by professional combat crews. The verdict was in, and it was unambiguous. One thing remained: to sign the order for serial production. It was at exactly this moment that the system broke down, and that breakdown had a specific name, a specific title, and a specific office in Moscow. Alexander Sergeyevich Yakovlev held a position during the war years that on paper was called Deputy People's Commissar of Aviation Industry. In practice, it meant something considerably weightier. He was Stalin's personal aviation advisor, a man whose word in a report to the leader could shut down any program or open any budget, a man whose own aircraft, the Yak-1, the Yak-7, the Yak-9, formed the backbone of Soviet fighter aviation, and a man who understood better than anyone else that if the I-185 entered serial production, his own machines would become surplus to requirements. A conflict of interest so obvious it could not be missed. But in the Soviet system of 42, noticing such things out loud was extremely inadvisable. According to available information, in one of his reports to Stalin on new aviation developments, Yakovlev did not merely omit the results of the I-185 state trials, he deliberately concealed the fact that they had taken place at all. A machine that had passed a full cycle of state trials and received a rating of best fighter from a front-line regiment became, in his account, an experimental aircraft that is still raw and has only just begun factory trials. Not a word about 680 kilometers per hour. Not a word about the field trials on the Kalinin Front. Not a word about the 728th Regiment report. If this account is accurate, what we are looking at is not bureaucratic caution or institutional inertia. It is deliberate disinformation, delivered personally to the Supreme Commander in the middle of a war. In his memoirs, written and published after the war, Yakovlev returned to the subject of the I-185 repeatedly, and every time, with the same set of arguments: excessive weight, high wing loading, inevitable increase in landing speed, reduced maneuverability, arguments that were technically literate, superficially persuasive, and profoundly dishonest, because behind each of them stood a deliberate omission. Yes, the I-185 was heavier than the Yakovlev aircraft, but it also carried an engine of fundamentally greater output, and its power-to-weight ratio, its thrust loading, was incomparably superior to any Yak in the inventory. Maneuverability is determined not by weight alone, but precisely by power-to-weight ratio and wing high-lift devices. The I-185 had both. Yakovlev did not write about this, deliberately. Meanwhile, pressure in favor of the I-185 was building from every direction. Test pilots filed reports. NIIVVS engineers submitted memoranda. Line pilots who had flown the aircraft on the Kalinin Front passed their assessments through every available channel. Some of these communications reached the Commissariat of Aviation Industry. Some went directly to Stalin. The information filter that Yakovlev had constructed around competing programs was developing leaks, and eventually, it burst. Through what appeared to be gritted teeth, Yakovlev was forced to authorize construction of a pre-production series of the I-185, but, and this is fundamentally important, exclusively with the M71 engine. Work on the M82 variant was officially terminated at the same moment. The formal explanation sounded reasonable enough. The M82 had by that point been installed in the Lag-3 airframe, producing the La-5 fighter, which was already in serial production. Retooling production away from the La-5 and back to the I-185 with the same engine was declared impractical and damaging to industrial output. On the surface, the logic appeared watertight. Beneath it lay a reality that people in the aviation industry understood perfectly. The La-5 was heavier than the I-185, inferior in speed, inferior in armament, inferior in power-to-weight ratio. In essence, its only advantage over the Polikarpov machine was that it was already being produced. The principle of the inferior but already established won out over the principle of the superior but requiring industrial adjustment. In wartime conditions, such logic had a legitimate claim. But the question of who exactly had ensured that the M82 became paired with the Lavochkin airframe before the Polikarpov machine had any chance at serial production, that question never received an official answer. February of 43. Factory number 81 begins preparation for deploying serial production of the I-185 with the M71 engine. It seemed the aircraft had broken through. 3 years of work, evacuation, war, bureaucratic barriers, and political maneuvering, and it had broken through nonetheless. Very little remained. Start the production line. Transfer the blueprints. Begin pilot training. Nobody in Polikarpov's design bureau knew that this story had less than 2 months left before its resolution, and that the resolution would come not from Moscow, not from the commissariat, and not from Yakovlev. It would come from a test airfield in April of 43. On the 5th of April, 1943, a routine working morning was underway at the test airfield of Factory Number 81. No warning signs, no indication that this day would enter Soviet aviation history as one of its darkest. Test pilot Vasily Andreevich Stepanchenok was preparing for a scheduled long-range test flight in the I-185 prototype with the M71 engine, a routine test sortie, one of hundreds Stepanchenok had completed in his career. The last one. The takeoff was normal. The aircraft climbed, settled onto its heading, and then, at low altitude, at the precise moment when there was virtually no height remaining for maneuvering, the engine stopped. It did not sputter. It did not begin running rough. It did not give the pilot time to assess the situation and make decisions. It stopped, sharply, finally, without warning. Stepanchenok found himself at the controls of a machine weighing more than 3 tons, traveling at a speed incompatible with a forced landing in the nearest field, at an altitude that gave no opportunity to select a suitable area. Directly ahead stood the factory hangar. Eyewitnesses later described those seconds in identical terms. Stepanchenok did not attempt to turn away. There was nowhere to turn. He did not eject. Soviet fighters of the period carried no ejection equipment. In the fractions of a second remaining to him, Vasily Andreevich made the only decision that offered any chance of reducing casualties. He aimed the aircraft at a window opening in the hangar wall. Not at the wall itself, at the window. The calculation was simultaneously precise and hopeless. If the fuselage could pass through the opening, the wings would be sheared off by the side walls, and the aircraft would lose speed before striking anything inside. That is exactly what happened. The wings were sheared off. The fuselage passed through the opening and struck a factory assembly jig. Stepanchenok did not survive the impact. One worker present in the hangar at the moment of the crash also did not survive. 6 more received injuries of varying severity. By the standards of wartime industrial accidents, the casualties could have been far heavier. By the standards of what happened to the I-185 program after that day, it was more than enough. The investigation moved quickly. The commission established the cause of the engine failure, and at this point, the story of the I-185 took a turn that left everyone who knew the program breathless. A piece of copper locking wire had been found positioned under the seat of a carburetor valve in the M71 engine. A small piece of copper wire, placed either deliberately or accidentally in precisely the location where it would produce maximum effect. The engine ran rough, lost power, and at the critical moment, in flight, at low altitude, stopped completely. Copper wire inside the carburetor of an aircraft engine is not a manufacturing defect and not the result of careless assembly. Such wire does not get there by accident. The official investigation produced no definitive answer to the question that immediately arose among everyone connected with the program. Whether this was deliberate sabotage or a tragic coincidence, the commission did not determine. No individuals were officially named as responsible. Any criminal case that may have been opened on grounds of possible sabotage did not reach a public conclusion. The question remained open, and remains open to this day. But those who had known the history of the I-185 from the first blueprint to the last flight, who had watched the apparatus grind the program down year after year, who had read Yakovlev's memoranda and heard the commissariat's explanations, those people drew their own conclusions, silently, because drawing them aloud in 43 was a matter of mortal consequence. The People's Commissariat of Aviation Industry responded immediately, not after a week, not after additional investigation, not after consultation with Polikarpov's design bureau. immediately. By executive decision, all work on serial production of the I-185 was terminated. A program that had survived evacuation, war, political maneuvering, and 3 years of technical trials was closed within days of a single accident. A single accident across the entire lifespan of the program. For comparison, other aviation programs of the same period survived far more serious losses of prototypes and test pilots, and continued. The I-185 did not continue. The speed with which the closure decision was taken and executed speaks more eloquently than any official explanation. Vasily Andreevich Stepanchenok was a first-class test pilot dedicated to his profession and his country. He departed by aiming his aircraft at a window rather than a wall, and in doing so, quite possibly preserved the lives of those inside the hangar. The program he had been testing departed with him. Whether this was coincidence or not, each person decides for themselves. Ask yourself one simple question. If the I-185 was the best fighter in Soviet air forces by the assessment of a frontline regiment, by the conclusion of state trials, by the evaluations of first-class test pilots, what would have happened to all other Soviet fighters if the Polikarpov machine had entered serial production? The answer is embarrassingly obvious. The Yak-1, the Yak-7, the Yak-9, all of these aircraft would have instantly become second-tier hardware, rolling off production lines by institutional inertia alone. The Law-5, with its excess weight and inferior characteristics, would have been consigned to history's scrapyard before its pilots had properly learned to fly it. Soviet fighter aviation would have received one aircraft, the best in the world at that moment, instead of 3 mediocre types produced in parallel, consuming resources the country was catastrophically short of. And now the second question. How long would Alexander Sergeyevich Yakovlev have remained in his seat as Deputy People's Commissar of Aviation Industry when his aircraft formed the backbone of precisely the fighter force that the I-185 was making obsolete? In the Soviet system, the post of Deputy Commissar was not held by personal merit or years of bureaucratic service. It was held by usefulness, by how much the output of your design bureau was needed by the state right now. Yakovlev understood this better than anyone, because he had spent years constructing exactly this system of dependencies, skillfully weaving personal career interests into state aviation policy. The disappearance of demand for Yakovlev fighters automatically meant the disappearance of demand for Yakovlev himself in the position he occupied. But the story does not stop at career motives. There is a detail that Yakovlev himself carefully skirted in all his numerous memoirs and public statements. Throughout the entire war, he never managed to produce a fighter with an air-cooled engine, not for lack of trying, because he could not do it. The structure of Yakovlev's airframes, which he described in his own writings as high production weight culture, meant in plain language that the airframe was too light and too fragile to carry a heavy, vibration-intensive radial engine. Whenever engineers attempted to install an air-cooled engine in a Yakovlev airframe, the structure could not take it. Vibrations destroyed attachment nodes. Loads exceeded calculated values. The aircraft did not fly as it should have flown. Polikarpov solved this problem. His airframe was designed from the outset for heavy, powerful air-cooled engines, with the corresponding structural margin, the corresponding geometry of load-bearing elements, the corresponding developed wing high-lift devices that compensated for the higher wing loading. This is precisely why the I-185 with the M71 engine produced 680 kilometers per hour and 1.5 kilometers in a combat turn. This is precisely why the aircraft was accessible to pilots with limited training despite its fundamentally greater power output. Competent design compensates for power. Weak design compensates for nothing, regardless of how many elegant words about weight culture appear in a designer's memoirs. Now place these facts together. Yakovlev held the position of Stalin's personal aviation advisor. Yakovlev had direct access to the leader outside all official channels. Yakovlev, according to available information, concealed the results of the I-185 state trials from Stalin. Yakovlev spent years in his memoirs systematically discrediting the Polikarpov aircraft, emphasizing weaknesses and suppressing advantages. Yakovlev was the single individual in Soviet aviation for whom serial production of the I-185 threatened the loss of his position, his influence, and the state order for his own design bureau. And it was precisely through his direct and indirect participation that the I-185 program was systematically destroyed. First deprived of the M82 engine, then restricted in its access to combat trials, then closed permanently after a single accident. To name this directly is to accept responsibility for an accusation that in official Soviet sources was never formulated or refuted. The facts are laid on the table. The logic is constructed. The motive is obvious. The opportunity is undeniable. Direct proof of intent is absent. It is precisely in this gap between the obvious and the proven that the entire history of the relationship between Yakovlev and the I-185 resides. A history that Alexander Sergeyevich himself chose to rewrite in his memoirs, carefully, professionally, and by all appearances entirely deliberately. Polikarpov did not live to see the moment when it became definitively clear that his aircraft would never rise in serial form. Nikolai Nikolaevich departed in July of 1944, gravely ill, still working until his final days, never having received official acknowledgement that his last aircraft was the finest fighter of its time. Yakovlev outlived him by 44 years, wrote memoirs, received state prizes and honors, and returned several times in those memoirs to the subject of the I-185, with the invariable set of arguments about excessive weight and wing loading, as though repetition makes falsehood true. The program was closed, serial production was terminated, the prototype stood motionless in the workshops. Any other designer in Polikarpov's position at that moment would either have broken completely or shifted to something else, to tasks the system was willing to support, finance, and approve. Nikolai Nikolaevich did neither. Gravely ill, cancer had delivered its diagnosis long before the program was shut down. He continued to work, not because he believed in quick vindication, because he knew no other way, because he could see, as clearly as only those who truly understand their craft can see, what this aircraft could still become. On the drafting tables of the Design Bureau in 1943 and 44 lay projects that to this day read like documents from a parallel history. A history in which Soviet aviation industry gave Polikarpov what he asked for, on time and in full. A history that did not happen. The first direction, a boosted variant of the M71 engine. The calculated output of the boosted modification was 2,200 horsepower. For comparison, the standard M71 that gave the I-185 its speed of 680 kilometers per hour in state trials produced 1,650 horsepower, a power increase of 550 horsepower on an airframe that test pilots had described as carrying significant reserve in speed performance. This was not a cosmetic upgrade. This was a machine of a fundamentally different class. Simple extrapolation produced speed figures that in 1943 no serial fighter in any country on Earth could approach. The second direction, the M90 engine. The same M90 that from the very beginning, back in 1939, had stood first on the list of candidate power plants for the I-185. 4 years later, this engine had finally reached a point where it could be discussed seriously. By 43, the M90 had completed bench testing 3 times, which in Soviet engine development of that period meant real progress rather than laboratory optimism. Calculated output at boost, 2,500 horsepower. Moreover, the M90 had a smaller diameter than the M71, and a smaller engine diameter meant a narrower cowling, less frontal drag, higher speed. On the I-185 airframe, designed with structural margin for heavier engines, the M90 opened prospects that looked extraordinary on paper, but behind which stood entirely real engineering calculations. The third direction was ambitious enough that even in the context of Polikarpov's design bureau, it looked like a challenge to common sense. The M95 engine, a monster of Soviet engine development with a calculated output of 3,300 horsepower. The I-185 airframe combined with the M95 produced figures on paper that resist calm contemplation. An aircraft with that power-to-weight ratio, while preserving the aerodynamic cleanliness of the Polikarpov airframe, would have reached speed figures unattainable by first-generation jet aviation. Not a metaphor. Mathematics. The early jet fighters that appeared in the final stage of the war reached speeds comparable to what the I-185 with the M95 would have achieved according to calculated data, while remaining a piston aircraft with incomparably greater range, incomparably better low-speed maneuverability, and incomparably simpler maintenance under field conditions. All of this existed in the form of drawings, calculations, and project materials lying on the design bureau's tables. All of it required one thing: time and a state decision to continue the work. Time Polikarpov did not have. The state decision, neither. Nikolai Nikolaevich worked in conditions best described by a single word: against. Against an illness that claimed more of his strength with every passing month, against a bureaucratic system that had closed his principal project and showed no urgency about opening the next one, against the physical impossibility of doing what he was doing in the condition he was in. People who worked with Polikarpov in the last year of his life recalled the same thing. When it was physically possible, he came to the design bureau, sat at his table, and worked, not giving instructions, not receiving reports, working himself by hand on drawings of an aircraft that would never fly. A man whom Soviet aviation bureaucracy had pushed to the margins continued doing the one thing he could do better than anyone: designing aircraft, the finest aircraft of his time, the ones they would not let fly. In July of 1944, Nikolai Nikolaevich Polikarpov was gone. The illness he had ignored for as long as he could had taken its due. On the table lay unfinished drawings. In folders, calculations for engines that never found their way under the cowling of his last aircraft. On the test stand, the M90, which had completed bench testing 3 times and been installed nowhere. 3,300 horsepower of the M95, in a project nobody intended to realize anymore. The story of the I-185 did not end in the sky and not on a production line. It ended in the silence of a design bureau over the unfinished drawings of a man who was not allowed to complete what he had begun. Historians and aviation experts continue to disagree on the assessment of Nikolai Nikolaevich Polikarpov to this day, and that disagreement is itself telling. One side pronounces the word dreamer with undisguised condescension, a designer who time and again staked everything on engines that did not yet exist in usable form. A hostage to incompetent engine builders who promised power and reliability, and time and again failed to deliver. A man who outpaced his era by such a margin that the era broke him. The arguments of this side sound convincing, right up to the moment you begin asking the uncomfortable questions. What choice did Polikarpov actually have? To follow the path of Yakovlev and Lavochkin, adapting Western technical solutions, betting on proven low-powered engines, avoiding risk, not running ahead of what industry could support. That path offered one undeniable advantage. It was almost impossible to fall on it. A serial aircraft around a serial engine, a clear, safe, reproducible formula. That is how the Yaks were built. That is how the LA-GG evolved into the La-5, aircraft that fought, aircraft that were available in quantity. Aircraft that were outpaced by the best German machines in speed and vertical maneuver, gaps that Soviet pilots closed with numerical superiority and personal courage, not with technical superiority of their equipment. Polikarpov chose differently. He looked not at what existed, but at what would exist. Not at the serial engines of 1939, but at what Soviet engine development would become in 3 or 4 years. His calculation was correct in substance. The M71 was eventually developed. The M90 completed bench testing. The new generation of power outputs was becoming real. What proved wrong was one assumption, that the system would give his aircraft the time and the opportunity to wait for those engines. The system did not give it that, not because the aircraft was deficient, precisely because the aircraft was too good. This is the central paradox of the I-185 story. The aircraft did not lose to the Germans, did not lose in trials, did not lose among the frontline pilots who rated it above every serial aircraft in Soviet air forces. It lost to people inside its own system, people for whom its superiority was not a source of pride, but a threat to their personal position. This is not a story of technical failure. It is a story of how an apparatus destroys what does not fit its interests, methodically, consistently, and in full compliance with every formal procedure. Lavochkin and Yakovlev built good aircraft. Their due should not be taken from them. Under wartime conditions, within the constraints that industry imposed, they did what was possible, and they did it professionally. But between good and best in aviation lies a gap that no production volume and no designer's political weight can close. The I-185 was the best. This is not an authorial opinion. It is a state trials protocol and a frontline regiment report. Documents nobody officially disputed. They were simply preferred to be forgotten. For me, Nikolai Nikolaevich Polikarpov is not a dreamer and not a victim of circumstance. He is the image of what genuine engineering will look like. The will to build not what is convenient for the system, but what is correct in substance. The will not to retreat when engines fail, when programs are closed, when bureaucratic rivals rewrite reality in their memoranda. The will to work over the drawings of an aircraft that has already been shut down, inside a body that is already surrendering, because you know no other way and want no other way. It is easy to build what someone else already invented before you. It is easy to adapt existing solutions to your own airframe and call that design work. It is incomparably harder to see what does not yet exist, to believe in it deeply enough to spend years of your life on it, and to know that even if no one listens today, you are still right. Precisely this capacity, to know your own rightness against everything, is what transforms an ordinary man from Oriol, raised in a priest's family, who became an aircraft designer of world standing, into a figure discussed 80 years later. Not because he won, because he did not surrender, and that turned out to matter more than winning. The I-185 did not become a serial fighter, but it became something larger, proof that Soviet aeronautical thinking at its finest was equal to anything in the world. That thinking was not allowed to be realized, but it could not be erased from history, because the trial protocols survived, the regiment reports survived, and the figures in them speak for themselves. 680 kilometers per hour, 1.5 kilometers in a combat turn, the best fighter by the assessment of men who fought the war. That is Polikarpov's legacy, and no memoirs by Yakovlev can undo it. The story of the I-185 did not end in 1944. It ends every time it is forgotten, and it begins again, every time someone asks the right questions. You watch this video to the end, which means you are one of those people for whom this matters. There are quite a few of you here, and every one of you made this channel what it is. If this story got to you, hit the like button, not for the numbers on the screen, so that the next person who needs to find this material finds it before the algorithm buries it. Subscribe to the channel and turn on the bell, because the next story is waiting, and it will be no less unsparing. This channel does not say what is comfortable to hear. It says what actually happened. Until next time.